So we saw different type of network options that we have in OSPF and BMA. This is a summary of the differences, network type differences, NBMA network mode differences. The default mode, when we have frame relay as a encapsulation on the interface where OSPF is already running, or you have OSPF encapsulation, frame relay encapsulation followed by OSPF, doesn't matter, any vice versa. You should have both frame relay and OSPF on that interface. If you have such a interface circuit link, then that link will be in a mode called non-broadcast mode. This is the default mode. This is default. In this mode, the hello packets are sent only every 30 seconds, not 10 seconds. And the dead time is 4 times of hello, which will be 120. In this mode, neighbors are not dynamically discovered. We need to configure manually. The reason is the address 224.0.0.5 will not be used. In non-broadcast mode, that particular address will not be used because it is called as non-broadcast. You cannot have that multicast support. If multicast is supported, then there is no point of calling it as non-broadcast. So non-broadcast mode cannot discover neighbors dynamically. So need to configure neighbors manually. When you configure neighbors manually, make sure the neighbor address is reachable because there is no hello packets going to be sent to discover the neighbor. Only the point to point. Sorry, I should not use the word point to point. Only the neighbor packet goes as a unicast. That's what I mean, unicast. Only using unicast, the negotiation is going to be between these two routers. That init state is not using multicast. It is going to be using the neighbor address that we give. So make sure that neighbor address that you assign is reachable. So after you configure neighbors manually, you will see this mode will start electing DR, BDR in the start state. See, if it is full mesh, having DR, BDR is okay. Not okay, it is good. But when it is hub and spoke, let's say this is the hub router. These are spokes. So here, the hub assume that this becomes DR and this becomes BDR. And these are all others. Why this is not recommended? This DR BDR election, if you have, then it is not recommended for this hub and spoke topology. You see, it's not recommended for hub and spoke topology. Why? It is only for full mesh. It is not for hub and spoke topology. Because if this link goes down, let's say this link goes down, can any of these spokes interact? No. They will all become an individual device. because the hub itself has gone down. Without hub, these three guys cannot know each other. Hub is the mediator. Now when hub goes down, this all will become dr. What is the use? This all will declare themselves as dr. And they don't have any communication. The frame relay needs hub. So what I'm trying to say here is, if you are not having full mesh or partial mesh, don't go for this. You need to change the mode. When I have full mesh, what does that mean? These are also connected. That is full mesh. Now if the hub goes down, no problem. Because these three can communicate, the BDR will become DR and this will become other. Because this DR has gone down. So wherever you see the DR BDR election, you will see full mesh, full partial, full partial. There is no star, which is equal to hub and spoke. Right? So this default mode is recommended for full mesh because there's going to be a DR-BDR election. But there are some workarounds which you might have seen in that video. Next, point to point is the second mode that we are seeing here. In this, neighbors are dynamically discovered, which means when you switch to this mode by typing IP, OSPF, network, point to multi-point. When you put this command under the interface, the frame relay interface where the OSPF is running, when you put this in this command, it overrides the default. Default is non-broadcast. It overrides it with this one. And now the multicast support will be there as soon as you put this command. It will start using 224.0.0.5, send the hello packets, discover the neighbor dynamically. And the good news is there is no DR-BDR election, so it is recommended, it is okay to use in any topology. It need not to be a full mesh, even in nodes. In a hub and spoke or partial mesh, this can be used. Why I started from here? Because this is default. Why I went to this one? Because this is also RFC standard. In both, the neighbors need to negotiate from same subnet. Only in point to point, each neighbor will be in different subnets, so you will be using sub interface on the hub router, which you might have seen in the video. Now, after you finish this 2 laps, you might have seen in the video me showing this one. This one is the combination of the above two. You see the name, point to multi-point, non-broadcast. This is the combination of the above two. Cisco came up with this idea of merging these two to achieve this one. What? Neighbors are manually configured like non-broadcast, which is good in an NBMA. Because it's an NBMA untrusted network, discovering neighbor dynamically is not that reliable. So discovering neighbors manually is much reliable. Discovering neighbors, sorry, configuring neighbors, not discovering. Configuring neighbors manually is much reliable. This is away from the syllabus. First, what we said is we will not configure every single router with OSPF, BGP, MPLS. We need application oriented. We need a centralized. That's why ACI, SD-WAN, all this thinking. It is very difficult for us to go to every single router and configure them. So we need a centralized automation tool, like we have Epic in ACI, like we have vManager in SD-WAN. Slowly, this technology, see how it is going to make the people foolish. What they are going to do is, we will also take control of the brains of the people. Now, every brain is individually thinking. Why we should allow the brain to think individually when we are ruling the country? When the internet is ruling the world, why can't we make people to think what we want them to think? We want people to think the way that we want, not their own. So, like a SD-WAN edge device, if all our brains need to work, they need to insert the chip on your brain. I'm not joking. It has already been tested. You have nothing to do of your own anymore. Already internet is controlling your brain. That's why, Jana don't want to see it. Because that is driving us. Already it is driving. Now this is going to be much more dangerous. One step more. Even if you try to avoid YouTube, no, man. You think the way that I am thinking. I'll put a chip on you. Otherwise, you cannot buy anything in your market. You cannot buy rice. If you don't have Aadhaar card, you cannot buy rice. If you don't have Aadhaar card, you don't have any bank transaction. That is today. Tomorrow, if you don't have this chip, you are a terrorist. Because we don't know what you are thinking. You are thinking to spoil the government. So better you have this chip to prove yourself. And everyone will be forced to have this. And this is going to happen in future. They will not say all these things. They'll say, hey, it is very good. You no need to speak, You see this one? You no need a phone. This picture here. No more phones. You don't need a phone. You see why you buy a phone and then you put the password, everything. You keep all the bank details, all those Google Pay, and then lose your phone and lose your money. Everything is now safe. You'll put the chip on your brain. Whomever you want to pay, just speak to them over the air, not over opening your mouth. Just see them and approve through the eyes, and money will get transferred. Because you got the chip, he got the chip, and there is a radio wave, and the chip is transmitting what your brain says. See, this is how people are going to become mad, foolish in future. All right, the machine learning, the AIs are going to be the emperor. See who is sitting there on the throne. Not the God. The devil is taking the place of God and making people to worship. People will become this mad in future. And you see already this is a picture, a real picture. Picture number 2 is a real picture in Japan. They have kept the robot with AI intelligence, a robot which can speak like Buddha. And these people say, we want to worship this robot. Why? This robot speaks same like Buddha speaks. The Buddha is a statue. He's not speaking for this long. Now we have a robot Buddha who can speak, who can listen to us. So we are more impressed by this robot. So we want to worship this robot than worshipping that stone statue of of Buddha. That's what these monks. So this foolishness has already started. Right? This is all possible because of the internet, IPv6, AI, machine language that we are welcoming today. Tomorrow we cannot get rid of this even if you want to get rid. Okay, now that's for your thought. Coming back to our class. As a network trainer, I should spread this message of warning. If not, I'm fooling you all. So I have spoken, I have done my job. Let's come back to this OSPF. Non-broadcast, point to multi-point. Together, what do you achieve? You have the best of non-broadcast, which is neighbors need to be configured manually, and best of point to multi-point, which is no DR-BDR. Configuring neighbor manually is best. It is more safe. Using our brain, thinking of our own manually deciding is best than dynamic learning or someone pushing us. We don't need to think, you don't need to work, you don't need to study, you don't need to just, you're born, okay. We will make you as an aeronautical engineer. Fine. At the year of 5, we'll put this chip on your body, and slowly as you grow, through the chip you can do fast learning and you can become a aeronautical engineer at the age of 8. 3 years, you are an aeronautical engineer. Why you waste your human time? Now you can work as an aeronautical engineer. But your chip is not programmed to do any other thing. You can do only aeronautical engineering thing, so that you won't conflict with others' job. Okay. Likewise, doctor's chip, cleaner's chip. This is the future going to be when you welcome AI, when you welcome machine learning. Already people stopped learning networking like this. They say chat GPT, blah, blah, how to configure, blah, blah. It gives you 10 options, cut and paste. So no one wants to use their brain anymore. They want all shortcuts. This is going to lead the mankind to something slavery, dangerous world we are going to enter into. Already we are in, according to me, into the dangerous, after the Corona 2019, this has started full-fledged. Before that, many trainings were happening in corporates, but nowadays no trainings. Why? They don't want you to be trained. They say we have artificial learning, we have all those intellectual thing automated. We don't want human being anymore. And after a point of time to make people happy, they say, okay, don't worry. We will not do anything of our own. We will use your brain only. You will be still working. We will give you salary. You just give your body. We'll put the chip in the brain and we will pay you salary. That's all. You're also on hard disk. We'll insert, we'll use it, and if the hard disk is bad, what we do? Throw it. So as long as you work, your physics is good, we'll use you. Now that is how people are going to become. Okay, more of this is given. Third one is Cisco's thing. The fourth one, in the NBMA environment, if you want to have a broadcast experience, you go with this mode. IP/OSPF network broadcast. When you say this, neighbors are dynamically discovered. Because there is going to be a DRBD election, make sure your topology is full, or at least partial, not hub and spoke. All should be in same subnet. In all this four, no? The neighbors who want to participate, they all need to be in same subnet. Like frame relay 10.0.0.1, 10.0.0.2, 10.0.0.3. All need to be in same subnet. But in point to point, this can be 10.0.0.2, this can be 20.0.0.2. So now what you're going to do, you're going to take this physical interface, make two sub-interface, put one sub-interface with 10.0.0.1 VLAN 10, another sub-interface 10.0.0.2 VLAN 20. But because it's a frame relay interface, instead of VLAN, we'll specify the del C. The del C number for 10.0.0.2, what del C to take, DLCA number. To 20.0.0.2, this is 20.0.0.1. For 20.0.0.1, what del C to take. That's all. So this is just to know that once upon a time we were using this different network type, different network modes in NVMe. Today we don't have such environment like frame relay or X.25 or ATM. You may not need this, but you may need things like point to point. Even though you are in Ethernet mode, when you make it as a point to point, you get this behavior. There won't be DRBD election. You know, that is how we use this topic. All right, go through this and the previous videos that I gave you to understand this much better. You don't need to do lab because in lab you need frame relay. It's a waste of time. Better watch those videos that I gave where I am doing the lab there. Watch and then just for knowledge you learn it. And then make sure you know this table column very well with proper understanding. That is enough. We can move on to the next topic. Before I move on to next topic, do you have any question on this topic? NBMe mode. All right. If no questions,